Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Network outages and availability issues can manifest in various ways, and they remain some of the most frequent concerns in IT support. These problems include noticeably slow network speeds, domain name system failures, port flapping, and intermittent device disconnections. Unlike total outages, which are easy to spot, partial failures may only affect certain users, services, or times of day. These incidents can result from physical hardware faults or logical misconfigurations. The A+ certification places high importance on being able to identify and respond to these common network degradation symptoms effectively. One of the most visible symptoms of a network problem is slow speed. Affected users may report that web pages load slowly, file downloads take unusually long, or that online services time out before completing tasks. These delays may happen intermittently or persistently, and could differ depending on the time of day or the device being used. Speed tests conducted from the user system will typically show reduced download and upload throughput compared to expected performance. Recognizing the scope and consistency of the slowdown is the first step in determining its cause. There are many causes behind slow network performance. Network congestion is common in environments with many active users or background services like large file transfers or system backups. Poor cabling, such as bent or low-quality Ethernet cords, can limit transmission speeds. A mismatch in duplex settings, where one device expects full duplex and the other operates in half duplex, can cause packet collisions and performance drops. Malware infections may also silently consume bandwidth or interfere with normal data flow, making comprehensive diagnosis essential. To identify whether the network is truly operating below expectations, technicians should run diagnostic tools. Performing a speed test helps quantify the issue and offers baseline metrics. Comparing performance between wired and wireless connections may reveal whether the issue is limited to one segment. Resource monitors or task managers can show if the device is downloading updates or running background applications that consume bandwidth. These comparisons can reveal whether the problem lies in the network infrastructure or the client system itself. Port flapping is another network condition that disrupts connectivity. This occurs when a network interface continuously switches between active and inactive states. When this happens, connected devices lose and regain connectivity rapidly, causing routing tables to be recalculated and disrupting ongoing connections. Devices may temporarily appear offline, only to return seconds later. Port flapping often points to hardware problems, including bad cables, failing network interface cards, or unstable switch ports. The underlying causes of port flapping vary by environment. Loose cables can make intermittent contact, causing a physical link to drop and re-establish repeatedly. Faulty ports on switches or routers can exhibit similar behavior. In more advanced networks, improper configuration of trunk links or errors in spanning tree protocol settings can also trigger link instability. Technicians should examine device logs and LED indicators to verify whether flapping is occurring and where it is originating. Addressing it requires confirming both physical and logical stability. DNS failures are another critical form of network degradation. When DNS fails, users often report that websites will not load or return messages like DNS server not found. Interestingly, pinging a website's IP address may still work, confirming that the internet connection itself is functional. These issues slow down or halt access to web-based services, even if the rest of the network appears to be operating normally. Because DNS underpins almost all human-readable internet requests, its failure affects both speed and reliability. The root causes of DNS resolution failures include misconfigured DNS settings on the client, outages at the DNS server level, or timeouts caused by network latency. Some internet service providers experience DNS outages that block access to multiple domains. Malware or router firmware bugs may also interfere with DNS operation, redirecting traffic or failing to respond to requests. When DNS malfunctions, even small configuration errors can create network-wide disruptions for any service that relies on name resolution. To troubleshoot DNS issues effectively, technicians rely on several core tools and steps. The NS lookup utility can verify whether a domain resolves correctly through the configured DNS server. If not, changing the DNS settings to a public resolver like Google or Cloudflare can restore access temporarily. Flushing the DNS cache on the local machine removes outdated or corrupted entries. In some cases, rebooting the router or switching the client to obtain DNS settings automatically may resolve persistent failures tied to internal configurations. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Intermittent network drops are a frustrating symptom that can appear random to users but often follow a pattern upon closer inspection. Affected devices may lose connectivity for a few seconds or minutes, then reconnect without any user action. This behavior is frequently caused by unreliable physical connections, such as frayed Ethernet cables or unstable wireless signals. In some cases, the issue may be isolated to a particular system, port, or access point. Identifying the scope of affected devices helps determine whether the root cause is local or infrastructure related. Internet protocol conflicts and issues with dynamic host configuration protocol leases can also contribute to unstable network behavior. When two devices are assigned the same IP address, a conflict occurs that results in connectivity warnings or outright failure to reach the network. DHCP servers that exhaust their IP address pool or fail to renew leases can leave devices without a valid address. Technicians should review logs, confirm lease durations, and assign static addresses to critical systems if needed. Proper DHCP scope management prevents these disruptions. Outdated network drivers or firmware can impact the performance and stability of network adapters. Problems such as frequent disconnections, packet loss, or inability to connect may be caused by driver bugs or hardware compatibility issues. Updating the driver to the latest version from the manufacturer often resolves these problems. However, if a recent update introduces new errors, rolling back to a previous version may restore functionality. Verifying that the correct driver is installed for the operating system is a crucial step in network device troubleshooting. System and device logs are valuable tools when diagnosing network problems. Network equipment, such as routers and switches, may record interface drops, reboots, or configuration errors. On the client side, event viewer logs include details about DHCP requests, DNS failures, and adapter errors. Reviewing timestamps, error codes, and log messages helps build a timeline of the issue and can reveal root causes that are not obvious during live testing. Effective troubleshooting includes a review of both real-time behavior and historical system activity. A failing router or gateway device typically results in a loss of internet access for all clients on the network. When this happens, local resources such as file shares or printers may still be available, indicating that the internal network is intact. In such cases, rebooting the router is a common and often effective first step. Technicians should also check for power interruptions, uptime logs, or cooling issues that could cause the router to become unresponsive. Some routers offer diagnostics or self-healing functions accessible through their web interfaces. Ping and traceroute are essential tools for localizing the source of network problems. Technicians can begin by pinging the local gateway to confirm local connectivity. If that succeeds, they can ping an external address such as 8.8.8 to verify internet reachability. If pinging the gateway fails, the issue lies within the local network. Traceroute helps pinpoint where the data path breaks down by listing each hop between the source and the destination. Long delays or dropped hops indicate congestion or failure at specific segments. A practical example of port troubleshooting demonstrates the use of simple isolation techniques. A user complains of periodic disconnections and the switch port shows rapid blinking activity. Moving the network cable to a different port resolves the issue, confirming that the original port was unstable. If multiple ports on the same switch begin exhibiting similar symptoms, the switch itself may be failing. Replacing the device or reconfiguring faulty ports is part of standard remediation procedures in network environments. Power quality and environmental conditions often go overlooked, but can significantly affect network stability. Overheating devices may throttle performance or reboot unexpectedly. Power brownouts or voltage fluctuations can cause modems, routers, and switches to lose connectivity. Using an uninterruptible power supply ensures stable power delivery and allows graceful shutdown during outages. In managed switches, temperature logs can be monitored for spikes that coincide with failure events. Proper cooling and dust control extend the life of critical infrastructure components. Documenting outages and recording incident details helps build a clearer picture of recurring problems. Technicians should log which systems were affected, the time and duration of the event, and the steps taken to resolve it. Over time, patterns may emerge, such as daily slowdowns or frequent disconnections tied to specific hardware. These records support long-term planning, justify equipment upgrades, and help support teams collaborate more effectively. Consistent documentation is a cornerstone of proactive network management. In summary, network outages and degradation symptoms such as slow speed, DNS failure, port flapping, and intermittent drops require careful analysis and layered troubleshooting. Tools like ping, traceroute, speed tests, and event logs allow technicians to narrow down the cause efficiently. Eliminating issues one by one, from cables and drivers to DNS settings and ISP faults, ensures a structured resolution path. These real-world scenarios are emphasized heavily in the A+ exam and form a core part of modern technical support roles. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.